It is a staggering thought that every atom in your body was once packed into a point smaller than a grain of sand, and later forged in the heart of a dying star. Since it's 2026, we have even clearer data from the latest space telescopes about these early moments. But the core narrative of our 13.8 billion year journey remains the most epic story ever told. The Cosmic Dawn, 13.8 billion years ago. The universe didn't begin with an explosion into space, but rather an expansion of space itself. The singularity, all matter and energy compressed into an infinitely small hot point. Think of this as the ultimate compressed file. All the energy that would ever exist was concentrated in a point of infinite density. Big Bang and fundamental forces. Rapid expansion begins. Fundamental forces take shape. In a fraction of a second, the universe expanded faster than light, inflation. As it did, the rules of the game were set. Gravity, electromagnetism, and the strong and weak nuclear forces split apart. Formation of quarks and electrons. The universe is a primordial soup. The universe was too hot for atoms. It was a literal plasma soup of subatomic particles. Recombination, 380,000 years. The universe cools enough for atoms to form, mostly hydrogen and helium. Finally, the temperature dropped to about 3,000 Kelvin. Electrons latched onto protons to form hydrogen and helium. This cleared the fog, allowing the first light to travel across the cosmos. We see this today as the cosmic microwave background. Galactic assembly, 13.6 to 5 billion years ago. Gravity is the great architect of this era, pulling gas together to light the first fires. The first stars, population 3 stars. Massive, short-lived stars fused the first heavy elements. These stars lived fast and died young. They were massive and composed only of hydrogen and helium. When they exploded, they forged the first heavy elements like carbon and oxygen. Earliest galaxies, 13.4 billion years ago. Small gravity clumps begin forming the first galaxies. Small clumps of stars merged. By 13.4 billion years ago, the first proto-galaxies appeared, messy, chaotic blobs of light. The Milky Way, 13.2 billion years ago. Our home galaxy begins to take shape from merging gas clouds. It began as a series of mergers about 13.2 billion years ago. It has been eating smaller satellite galaxies ever since to grow into the spiral we know. Stellar generations. Generations of stars live and die, supernovae, seeding the universe with carbon, oxygen, and iron. Each supernova enriched the surrounding gas clouds. We are third-generation stars. Our sun contains the ashes of stars that died billions of years before it was born. The birth of our neighborhood, 4.6 to 3.8 billion years ago. This was a violent, chaotic era that turned a cloud of dust into the solar system. The solar nebula, 4.6 billion years ago. A nearby supernova likely triggered the collapse of a gas cloud, forming the sun. A shock wave caused a giant cloud of gas to collapse. 99.8% of that mass became the sun. Protoplanetary disk. Dust and rocks collide to form planets. Earth forms around 4 billion years ago. The leftovers flattened into a disk. Static electricity and gravity caused dust to stick together into planetesimals. The Hadean Eon, fiery Earth, and Theia. Earth is a molten ball of magma. It was a hellish landscape of lava. During this time, a planet-sized body called Theia slammed into Earth. The debris from this collision coalesced to form the Moon, which stabilized Earth's wobble. Late heavy bombardment. Comets and asteroids pelt the planet, likely delivering much of Earth's water. For hundreds of millions of years, Earth was pummeled by space debris. These comets likely acted as delivery trucks, bringing water and organic molecules to our parched surface. First oceans and atmosphere. As the crust cools, volcanic outgassing creates a primitive atmosphere, mostly CO_2 and water vapor. Steam condenses into the first seas. As the Earth cooled, water vapor condensed. It rained for millions of years, filling the low basins to create the first seas. The biological revolution, 3.8 billion to 541 million years ago. Life began as a chemical fluke and ended up rewriting the planet's chemistry. Abiogenesis, 3.8 to 3.5 billion years ago. The first simple, single-celled life, prokaryotes, appears near hydrothermal vents. In the dark, high-pressure environment of hydrothermal vents, complex chemistry became self-replicating biology. The Great Oxidation Event, 2.4 billion years ago. Cyanobacteria evolved photosynthesis, pumping oxygen into the atmosphere. This kills off many anaerobic species, but paves the way for complex life. This was Earth's first climate catastrophe. Cyanobacteria began exhaling oxygen. For the existing anaerobic life, oxygen was a toxic poison. However, this paved the way for the ozone layer, which eventually shielded the land from lethal UV rays. Snowball Earth. Drastic climate shifts lead to periods where the entire planet, or most of it, is covered in ice. The rise of oxygen lowered methane levels, a greenhouse gas, plunging Earth into snowball phases where ice reached the equator. Eukaryotes and multicellularity. Complex cells with nuclei appear, eventually leading to the first multicellular organisms. Life leveled up. Smaller cells were swallowed by larger ones, becoming organelles, like mitochondria. This allowed for the complexity needed for multicellular life. The explosion of life, 541 million years ago. Once life figured out how to be multicellular, it moved fast. Cambrian explosion. A massive burst of evolutionary diversity in the oceans. In a geological blink, almost all modern animal body parts, shells, eyes, skeletons, appeared in the oceans. Colonization of land. Plants, mosses, moved to land first, followed by arthropods and amphibians. Plants paved the way, stabilizing the soil. Arthropods followed, then fish evolved limbs to become amphibians. The age of reptiles and dinosaurs, and the Pangea, the Mesozoic era. The continents merged into one giant landmass, Pangea, which allowed land animals to migrate everywhere. This was the era of the dinosaurs. Then Pangea breaks apart. KPG extinction, 66 million years ago. An asteroid hits Earth, ending the reign of dinosaurs and allowing mammals to thrive. 66 million years ago, a 6-mile-wide asteroid ended the Mesozoic. By clearing out the giant reptiles, it opened a vacancy for small burrowing mammals to inherit the Earth. The rise of hominids. Human ancestors diverged from apes roughly 6 to 7 million years ago. The transition from apes to hominids was a survival response to climate change. As African forests thinned into open savannas roughly 7 million years ago, our ancestors were forced to travel between distant patches of trees. To survive, they adapted by standing upright. The human era, 300,000 years ago to today, the most recent chapter, is characterized by the shift from biological evolution to cultural evolution. Homo sapiens, 300,000 years ago, anatomically modern humans emerge in Africa, with brains wired for complex language and social cooperation. The Great Flood legends, end of Ice Age. Around 12,000 years ago, as the last ice age ended, sea levels rose rapidly. Glaciers melted and sea levels rose by 400 feet. This Great Flood likely became the foundational myth for civilizations globally. The Neolithic Revolution. Humans transitioned from hunter-gatherers to farmers. We stopped chasing food and started growing it. This led to permanent settlements, which led to specialized labor, priests, kings, builders. Early civilizations, Sumer, Egypt, Indus Valley. Writing, organized religion, and urban planning emerge. Around 3500 is 2500 BCE. Humanity transitioned from tribal life to complex statehood through 3 primary innovations. Sumer, Mesopotamia, invented cuneiform to manage trade and built ziggurats, establishing the first centralized city-states. Ancient Egypt, unified under a god-king, pharaoh, using hieroglyphics and monumental architecture, pyramids, to codify a complex eternal religion. Indus Valley, revolutionized daily life with high-precision urban grids and the world's first sophisticated sewage systems in standardized weights. The industrial and digital revolutions, Modern civilization moves from steam power to AI in just a few centuries. We went from the first steam engine to splitting the atom and creating AI in less than 300 years, a time frame that is effectively zero on a cosmic scale. The Holocene extinction. We are currently living through a major extinction event, but unlike the asteroid, this one is driven by the activity of a single species. Us.